So let's take a look at higher derivatives. Now what we have been doing so far is that we've been deriving only once and we've been finding the first derivative. So now with higher derivatives we're basically deriving over and over again to find things like the second derivative, the third derivative, the fourth derivative, and so forth. So let's say I have f of x equals x cubed. Then in this case, let's say we derive once, so f prime of x, the derivative, we use the power rule, is going to be 3x squared. So now in order to do higher derivatives, we just need to derive again. So the second derivative is just going to be f double prime of x is going to be equal to 6x to the first, or 6x. So then f triple prime of x equals 6, and then f quadruple prime of x, or in this case, anything greater than the third derivative is written as f to the fourth in parentheses. This is known as the fourth derivative of x is going to be equal to, well, the derivative of a constant 6 is going to be 0. Now keep in mind there are several different ways to writing the notation for higher derivatives. So let's say instead of f of x equals x cubed, we had y equals x cubed. Then we can also say instead of f prime, we say y prime. Instead of f double prime of x, we say y double prime. We go y triple prime, and then we can write the fourth derivative, which is just y to the fourth, written like so. And let's say instead of y prime, we had dy dx. Then the second derivative will be written as d squared y over dx squared. The third derivative, d cubed y, so I go ahead and rewrite that, d cubed y over dx cubed, and the fourth derivative is the exact same process here, d to the fourth y over dx to the fourth. So that's basically how you find higher derivatives. All you have to do is derive over and over again, depending on how many derivatives you want to find. So for this next set of problems, let's go ahead and find the first and second derivatives of the function. So for number 1, we have f of x equals x to the fifth plus 6x squared minus 7x. So in order to find the first derivative, f prime of x, all we have to do once again is derive. So derivative x to the fifth, we use the power rule, is 5x to the fourth, plus the derivative of 6x squared, which is going to be 12x to the first, or just 12x. And then we have derivative of negative 7x, which is negative 7. So now in order to find the second derivative, we just say f double prime of x. So the second derivative of the function is going to be, once again, same thing here. We use the power rule. Derivative of 5x to the fourth is 20x cubed, plus the derivative of 12x, which is going to be 12, and derivative of negative 7 is 0. So those are going to be the first and second derivatives of the function. Now for number 2, we have y equals cosine of 2 theta. So realize that we do have an inside function here, 2 theta, and our outer function is cosine. So we do have to use the chain rule. So y prime, when we derive or take the first derivative, we take the derivative of cosine of 2 theta, which is going to be negative sine. We keep the inside function the same. And then we go ahead and multiply by the derivative of the inside function. Derivative of 2 theta is 2. So then y prime is going to equal negative 2 sine of 2 theta. So now in order to find y double prime, the second derivative, notice negative 2 here is a constant, so we can rewrite it as negative 2 times the derivative. Now we're not deriving with respect to x, the variable is theta, so we derive with respect to theta of sine of 2 theta. Now similar to cosine of 2 theta, we do have an inside function, we do have an outside function. So let's go ahead and first find the derivative of sine, which is going to be cosine. So we do have the negative 2, so I'll write negative 2 times the derivative of sine of 2 theta, which is going to be cosine. We leave the inside function the same, 2 theta, and then we multiply by the derivative of the inside function. Derivative of 2 theta is just going to be 2. So then y double prime is going to equal negative 2 times 2 is negative 4. So we get negative 4 cosine of 2 theta. Those are going to be the first and second derivatives of the function. Now for number 3, f of t equals 1 minus 7t to the sixth. Notice we have an inside function, we do have an outer function. So we can go ahead and use the power rule combined with the chain rule. So f prime of t equals, we're going to bring the power down, keep the inside function the same, subtract the power by 1, 6 minus 1 is 5, and then multiply by the derivative of the inside function because of the chain rule. Derivative of 1 minus 7t is negative 7. So then f prime of t is going to equal negative 7 times 6, negative 42, times 1 minus 7t to the fifth power. So now, in order to find f double prime of t, the second derivative, notice we do have to use the chain rule or the power rule combined with the chain rule once again. Negative 42 is just a constant, so we can bring the power down once again. So negative 42 times 5. Keep the inside function the same. Subtract the power by 1, 5 minus 1 is 4, and multiply by the derivative of the inside function. Once again, derivative of 1 minus 7t is negative 7. Negatives will cancel, And so now for our final answer here, f double prime of t, we're going to get 42 times 5 times 7, which is going to be 1,470 times 1 minus 7t to the 4th power. Now for number 4, we have g of t equals t cubed times e to the 5t. Realize we do have two functions being multiplied by each other, so we do have to use the product rule when we take the first derivative. So g prime of t, once again, when using the product rule, is going to equal derivative of the first function, which is going to be 3t squared, times the second function unchanged, so times e to the 5t, plus the derivative of the second function. Now the derivative of e to the 5t, if I go ahead and we're going to derive with respect to t, because that's the variable, and I'm going to rewrite derivative of e to the 5t. Realize we do have an inside function here, so we have to use the chain rule. Derivative of e to the 5t is going to be e to the 5t times derivative of the inside function. Derivative of 5t is 5. So then we get 5e to the 5t. So once again, using the product rule plus the derivative of the second function, which we have found to be 5e to the 5t, times the first function unchanged, so times t cubed. So simplifying g prime of t here, we get 3t squared e to the 5t, and then plus 5t cubed. If I go ahead and rewrite that, 5t cubed e to the 5t. So now let's go ahead and find the second derivative. Now in order to find the second derivative, g double prime of t, realize there is a plus sign separating both of these functions, so we can take the derivative of each individual one here. So let's go ahead and take the derivative first of 3t squared e to the 5t. Now because 3t squared is being multiplied by e to the 5t, we have to use the product rule. So once again, we take the derivative of the first function times the second unchanged. So the derivative of 3t squared is 6t times the second function unchanged, plus the derivative of the second function. Now we've already taken the derivative of e to the 5t, that's going to be 5e to the 5t, times the first function unchanged, so times 3t squared. So now we have a plus here, and then we can take the derivative of 5t cubed times e to the 5t. Once again, using the product rule because we do have 5t cubed being multiplied by e to the 5t. So we take the derivative of the first function, derivative of 5t cubed is 15t squared, times the second function unchanged, so times e to the 5t, plus the derivative of the second function, derivative of 5, or e to the 5t once again is 5e to the 5t, times the first function unchanged, so times 5t cubed. So now we can go ahead and simplify here. So we get 6t e to the 5t plus, now 3t squared times 5 is going to be 15t squared e to the 5t, and then we have plus 15t squared e to the 5t again, and then we have plus 5t cubed times 5 is 25t cubed e to the 5t. So then we have 6t e to the 5t. Now 15t squared e to the 5t plus 15t squared e to the 5t is going to be 30t squared e to the 5t. So 30t squared e to the 5t. And then we have plus 25t cubed e to the 5t. Now if I want to, for my final answer, I can go ahead and factor out t times e to the 5t. So then we'll get 6 plus 30t. So go ahead and rewrite that. 6 plus 30t, and then plus 25t squared. And that's going to be the final answer for g double prime of t. Now, a couple videos ago where we talked about particle motion, we said that s of t is the position function, and so if we take the first derivative of s of t, we get velocity, v of t. So once again, v of t is equal to s prime of t. Now, if we go ahead and take the second derivative of position, or the first derivative of velocity, we derive one more time, we get the acceleration function. So acceleration is equal to v prime of t, the derivative of velocity, or the second derivative, s double prime of t, of position. Now keep in mind, you can go on for many different derivatives, like the derivative of acceleration is jerk, followed by snap, then crackle, then pop, and then lock drop. So there are like 8, 9 different derivatives, but really we're just focusing on position, velocity, and acceleration. So for this next problem here, given the position function s of t, s is in meters and t is in seconds, for part A, let's go ahead and find the velocity function, and then for part B, find the acceleration after 1 second. So right away we have s of t equals 2t cubed minus 15t squared plus 36t plus 2, where t is obviously greater than or equal to 0 because t is in seconds or is a measure of time. So let's go ahead and find the velocity given the position function. So if s of t is position, then v of t is just going to be the derivative. So we take the derivative of 2t cubed, which is going to be 6t squared, minus derivative of 15t squared is going to be 30t to the first, or to 30t, and then plus derivative of 36t, that's going to be 36, and derivative of 2 is 0. So this is going to be the velocity function for part A. Now for part B, we have to find the acceleration after 1 second. Remember, acceleration is the second derivative of position, or the first derivative of velocity. So let's go ahead and derive velocity to get acceleration. So derivative of 6t squared is 12t to the first, minus derivative of 30t is 30, and derivative of 36 is just a constant, so derivative is 0. So this is going to be the acceleration. And we need to find the acceleration after 1 second, so all we have to do is plug in 1 for t. So a of 1 is going to equal 12 times 1, which is 12, minus 30. And that's going to give us an answer of negative 18. Now our units here. Remember that s is in meters and t is in seconds. So the acceleration is written as meters per second squared.